here we are going to look at another A-level problem today. This is 2019 Combined Mathematics paper, second problem. As you can see, I already got started with it. I have the graph ready. But what the question is asking, let's look at that. So this says, sketch the graph of y equals 4x minus c absolute, and then 3 minus 2 absolute x. These are the two graphs I have for those two. The orange one here will be the one that has the negative with the x term, because you know the absolute of x usually gonna look like that. So if you have the negative in front of the absolute, it's gonna just flip over, making that V shape flipped over. So this orange one should be the one that has the negative with the x. So that's my 3 minus 2x, and then this one 4x minus 3 all inside the absolute value, but this here has no negatives in front or anywhere, so this is kind of my regular V shape, but it is shifted a little bit. But the red one is this 4x minus 3. Now once you get the graphs, I just started by drawing the graphs for you, because that is the easy part. You know how to draw your graphs when it is given. And in this second problem, usually you have the absolute inequalities to deal with like this. So what we have to do after you have the graphs is it says hence or otherwise. When it says hence or otherwise, it's usually gonna go through hence, that you use the given graph to come up with this one. Let's see how I do this. Now, before I go further, I want to know what these intersection points are. It looks obvious once you do the graph correctly, but when you do the graph, if you didn't know what these points are, you cannot draw it like this. So when you draw it, you should at least know where these intersections are. So how do we find these intersections? We equate the two equations and solve for the intersections. That's how you usually do it. So this function equal to that function at what points? If I write that directly like this, so I have 4x minus 3. If I equate to this one, and now I have to solve this to find what x values give us this graph to have the same values. So the equality will give us the values that the x values are becoming the same when the function values are the same. But solving this is not straightforward. You have to do lots of things because we have absolute bars around it. So how do we look at this problem to get these intersection points? This is one major point of this problem, so make note here. Even pausing this video and thinking about this will be a good idea. Now let's get rid of that, because that's going to take some time to work. Instead of labeling these two graphs with the absolutes like this, how about I just think about, let's think about this 4x minus 3 absolute. How about I just think about the right side, the line like this, and the left side, the line like that. These are just lines when you think about the right and the left sides of this V shape. So if the whole graph is 4x minus 3, we know the absolute works like this. For example, if I have x absolute, then we define this as x positive when x is greater than 0 or is equal to 0, or negative times x if x is less than 0. That's how we look at the absolute. So then 4x minus 3 absolute should be defined the same way. You're gonna get with the 4 in the front, and then with the minus in the front, the same thing, like that. So in one case, you see I'm gonna get 4x minus 3 with, and this looks like a line, y equals mx plus c form. So 4x minus 3 gives us a slope of 4, a positive slope. Now it tells me something. If this V shape is all that, When you think about just the absolute parts removed, it's going to be just 4x minus 3 with a positive slope. And from the two lines I have, this one and the other one here, this one has the slope positive. So then this must be my positive 4x minus 3, this line here. And then what is this line here then? Negative 4x minus 3. In other words, this is just negative 4x plus 3. And it has a negative slope. And this line has a negative slope. So this side must be the other part. So this is my negative 4x plus 3. So writing the two parts of the absolute curve like that, positive and negative, helps a lot in these problems. So rather than having this label, try to write it like this. So same thing here. Now I have absolute x. We know absolute x is positive x or negative x. Now what do you think? If this is positive x, we are going to have 3 minus, if you think about 3 minus 2x. This is going to have 3 minus 2 times negative x and positive x. So if I first consider the positive part, I'm going to get just x, so 3 minus 2x. And when I consider the negative part for x, then it's going to make this one positive, so I'm going to get 3 plus 2x. Now out of these two, this one has a negative 2x, and negative 2 is a negative slope for a line. So which of the two lines has a negative slope? This one does. So that one has a negative slope. Therefore, this side must be my line. This one must be my 3 minus 2x. And this one has a positive slope too. And this line is a positive slope. This side must be my 3 plus 2x. So instead of having this, I broke it down to these two for the two lines. Now things are going to be a little simpler. Rather than solving the absolute equations to find the intersections, now only thing I have to do is what? The intersection between this line and that line. That means this equation equal to that one gives us the intersection here. And intersection between this line, you can either use this one or this one, doesn't matter which one you use. If I use this one and that one, then I'm gonna get this intersection. I think you get the idea. So let's get rid of this. We don't need this anymore. To find the intersection shown here, I'm gonna use this as we discussed. So my work is equate 4x minus 3 to 3 minus 2x. And that is a simple one to work with. So you get 6x equal to 6, giving us x equal 1. And at x equal 1, as you can see here, x equal 1 gives us that intersection. And that gives us y equals 1 as well. So that's 1. And then let's equate this one to this line to get this intersection here. So I get negative 4x plus 3 equal to 3 plus 2x. So I'm going to get 6x equal to 0. So x equals 0. That's my other intersection. So 0 gives me this intersection here. I just found the intersections so that I know where the graph is crossing each other. Why do I need that? That will be helpful when you use the graphs to answer the question. When it says hence or otherwise, as I said earlier, try to use the hence part. Otherwise would mean you don't use this, the graphs you just did, you're gonna go in a totally different area of method that you come up with. but hence would help you to use the graphs. Okay, now you have an inequality here. The graph gives you inequalities. Now you see this part of the graph is bigger than this part of the graph. The red graph is smaller than the orange graph in this area, which is from 0 to 1. So that's something we are looking for here. It says find all real values of x satisfying the inequality. So I had to find the values of x satisfying inequality. How about I try this? 0 to 1, I have the orange graph smaller than, the bigger than the red graph. And that is how you look at this. When you have the graphs, you have certain inequalities in it. So knowing this second problem, if you think about past papers, also you have similar problems, the method is always the same. A-level is just take one at a time, it's gonna be easy. So let's do this here. Have those intersections 0 and 1, you don't need those basic forms changed to give the line equations of line separately. So I'm going to use the basic equations that we started with, and let's see how we use this inequality shown in the graph between the orange and the red curves to come up with the solution that we are looking for. Now between 0 and 1, we know the orange curve is bigger than the red curve. So I can write this. I can say between the values of 1 and 0 for x, I'm gonna have the red curve, which is 4x minus 3, to be smaller than 3 minus 2x. Now starting with this, I'm gonna create this situation. I see a 3 in the bigger side. I see the 3 here. And there's nothing like negative 2x. How about we move this to the other side? So I'm gonna get 4x minus 3 plus 2 absolute x less than 3. This is almost like that, but we have, see, when we have a negative 3 inside the absolute, we have a 2x instead of a 4x. Here we have absolute x, here we have a 2x. So let me do this first. I'm going to do this. I'm going to move this 2 inside the absolute. It shouldn't do any difference because it's a positive 2, so you can move it in, so you know out the absolute. Now what do you see? You see the absolute, we have x here in the given problem, and this is double of that. And I see the same relationship. I have 2x, I have double of 2x, which is 4x. That's the relationship I need in here. Just whatever here doubles that. So to get it to look like that, all I need is a change of variable then. Because I have the relationship between the variables. As long as I have something here, it doubles there. So how do I make this look like that? I have a 2x to make it look like x. If I replace this x with a x divided by 2, these 2's will be cancelled and I'll get the x. If I replace this x with x over 2, then I'll have to do the same here. And what does that do? If this is x over 2, that's going to cancel the 4 and gives us the 2x. And now we have it. Let's do that. So we have replace x with x over 2. X replaced by x over 2 tells me 4x over 2 here minus 3 plus 2x over 2 there less than 3. And now you see we have 2x minus 3 plus bx less than 3, the exact same thing I have here. Now these x values between 0 and 1 was valid for this one. I just did a change of variables. So if x is moved to that one, now my x is replaced by that. Therefore, the new inequality should be x over 2 between 1 and 0. Now that's the relationship I need in order to have this inequality. So x over 2 is between 0 and 1. What does that tell me? Remember what we are looking for here. Now the problem is asking find all the x values satisfying this inequality. The inequality is not the major part. The values that gives the inequality. So x over 2 between 0 and 1 gives us this inequality. And that means what? That means if I solve for x, I get 0 multiplying everything by a 2. you get x between 0 and 2. So the given inequality is satisfied when x is between 0 and 2. There we have it. We use the graphs, hence is what we use. We use the graphs to get to our final answer. Try another past paper problem like this, which I will be adding as another video. You can check that out later. So thanks for watching. See you in another video.